Dear students, in this video you are going to learn about electrical energy and electrical power. Now what is electrical energy? Before going to discuss about electrical energy, I would like to recap the concept which you have learned in your class 9. That is work done as well as energy. Generally, if you see, energy is the cause, work done is the effect. That means whenever you want to perform some work, you need energy. Without energy, you cannot perform work. Once you perform work, again the energy utilized to perform that work will store in the form of another energy. So that's the reason we'll say in conservation of energy, energy can neither be created nor destroyed but can be transferred from one form to another. So whenever you want some energy, you have to perform some work. So by performing some work, you will convert one form of energy into another form of energy. That's the reason we say energy is the cause and work is the effect. Now, how can we define electrical energy? Now, it is the amount of work done to maintain the flow of current in a conductor. So generally, whenever you are going to connect a battery to a conductor, the current starts flowing from one end to the other end of a conductor. Now, in order to move the charge from one end to other end, you have to perform some work done. That work done to move the charge from one end to other end will store electrical energy. So simply, energy is nothing but work done alone. So that work done to move the charge, whenever you apply potential V across the ends of the conductor is W is equal to Q into V. This we have learned in potential difference, because potential difference is nothing but what? Work done by charge. So W equal to Q times of V. Now if you see the definition of current, what is the definition of current? Rate of flow of charge, that is nothing but Q by T, charge per unit time. So from this, if you write the expression for charge as I into T, so substitute here, you are going to have work done equal to I into T into V. Now by using Ohm's law, V is nothing but what? I into R, because every conductor will have certain resistance. So V equal to I into R. Substitute the value here, you are going to have the expression as W equal to I square RT. So this is the electrical energy stored in a conductor. Now what is the SI unit of electrical energy? Any energy is measured in terms of joule. So the symbol is capital J, which is a scientist name. Now, what is electric power? The power is nothing but what? The rate of doing work, or simply we can say work done per unit time. So the rate at which electric current is used is determined in terms of electric power. So power is nothing but what? Work done by time. What is work done? Already we have defined here I square RT. So if you substitute here I square RT by T, so T gets cancelled, you are going to have the expression as I square R. Still I can rechange this expression. How? By using Ohm's law, R is nothing but what? V by I. So which is equal to I square into V by I. So I gets cancelled, I into V. So our power is nothing but I into V. So what is the SI unit? So the SI unit of power is nothing but watt, because if you see work done by time or I into V, this is the formula. Work done by time is nothing but what? Joule per second or ampere times volt. So 1 joule per 1 second is nothing but 1 watt, or 1 ampere into 1 volt is nothing but 1 watt. So 1 watt is the power when 1 ampere of current flows across a potential difference of 1 volt. So this is the SI unit of power. Generally, watt is a very small unit. So we are going to use some other practical units like kilowatt hour as well as horsepower. If you see the train engines, the power of an engine is written in terms of either kilowatt or horsepower. What is kilowatt? Kilowatt is nothing but 1000 watt. Kilo means 1000. So 1000 watt is nothing but 1 kilowatt. Similarly, 1 horsepower is nothing but 746 watt. Commercial unit of energy. Generally, every home is going to use electrical energy to fulfill their needs. So the amount of electrical energy that you have consumed is measured in terms of a unit called commercial unit of energy. That is nothing but kilowatt hour. Hope everyone is having a meter in the first room or in the front of your house, which is called electric meter. Now, whenever you're going to use electrical energy, that meter will determine how much energy you have consumed in that particular span of time. Let it be 1 month. So the electrical department is going to come and say that you have consumed 100 units, for instance. So what is that unit actually? That unit is nothing but kilowatt hour. So the energy consumed in your home or in industry is measured in terms of a unit called kilowatt hour. So what is kilowatt hour? See here, kilowatt hour. Kilo means 1000, watt means watt or joule per second we can write, and hour means 3600 seconds. So if you're going to cancel second by changing watt as joule per second, you're going to have 3.6 into 10 to the power 6 joules. So this is the conversion factor and most important which can be asked in the examination, commercial unit of energy. So commercial unit of energy is the unit, practical unit which is used to measure the amount of electrical energy consumed by either home or industries. Remember, this is not the unit of power, this is the unit of energy. So the commercial unit of electrical energy is kilowatt hour. 1 kilowatt hour is the power consumed when 1 watt of power is used for 1 hour.